Now that we know how to solve quadratic equations, the next thing we're going to do is graph them. So today we're going to focus on finding critical points. By the end of this lesson, you should be able to find the number of real solutions of a quadratic equation and be able to graph one by finding its critical points. So far we have looked at the quadratic equation. And remember, an equation has an equal sign on it, and we always want it equal to 0 so that we can factor, plug it in the quadratic formula, or do one of the ways that we know how to solve it. From now on, we're going to be looking at quadratic functions. And a quadratic function is a graph of your quadratic equation for all of its points. And the examples look like this. If you notice, they don't equal 0 anymore, they equal y. Just like when we had y equals mx plus b, that was a linear function that we could graph. Now we're doing y equals ax squared plus bx plus c. So the solutions of a quadratic equation are the x-intercepts. That's why we call those zeros of the function or roots of the equation. So all of the solutions that we found over here, like x equals 2, these are x-intercepts. And we'll need those later today. So remember, quadratic equations can have 2 answers, 1 answer, or no real solutions. You can determine how many solutions a quadratic has before you solve it by using the discriminant. And the discriminant is part of the quadratic formula. So here's the whole quadratic formula down here. The discriminant is just what's underneath the square root. And this tells us how many solutions something has. It doesn't tell us what the solutions are, but it'll tell us if we have 2 solutions, 1 solution, or no solution. So think back to when you use the quadratic formula. If you got a positive number underneath the square root, you ended up with 2 different answers. You did like the opposite of b plus something divided by 2a, and then the opposite of b minus something divided by 2a. So if we take a look at this equation right here and plug its parts into just the discriminant, the b squared minus 4ac, we end up with a nice, pretty positive number. When you have a positive number, that gives you 2 real solutions. If you plug all this stuff into the discriminant and you get 0, remember you'd have negative b plus or minus 0 divided by 2a. So you don't need to add 0 and subtract 0, you just end up with 1 solution. So if it's 0, you get 1 real solution. And if it's positive, you get 2 real solutions. Now, if you plugged everything into the quadratic formula and you got a negative number underneath the square root, you know that you can't take the square root of a negative number. So you would stop right there and you would say no real solutions. And in that case, this graph never crosses the x-axis. So if you get a negative number, it means no real solutions. It has imaginary solutions, which you'll have to wait until Algebra 2 to figure out exactly what those are. But remember, your solutions are the x-intercepts. So if you have 2, it crosses twice. If you have 1, it only touches. And then if you have none, it does not cross the x-axis. So you're going to get some problems that just ask you to find the number of solutions. I'm not asking you for the actual solution. I just want to know how many times does this cross the x-axis. So the first thing you got to do is make this equal 0, and it doesn't really matter what side you put this on. And then you have to plug it into just what's underneath the square root of the quadratic formula. So just like before, we're going to label what a, b, and c are. A is 1, b is negative 2, and c is 3. And then we'll plug them in. So negative 2 squared minus 4 times a times c. Gives me 4 minus 12, which is negative 8. So this negative number right here, I don't care that it's negative 8, but because it's negative, this tells me that there are no real solutions. And we're done. We can do the same thing with this one, make it equal to 0. Pick out our A, our B, and our C. 3, -4, -7. And then plug it into just the discriminant. So -4 squared minus 4 times A times C. This gives me positive 16. And this, we end up with 12 times 7. And then we get 100. So because this is positive, I don't really care what the number is, but because it's positive, this means that I have 2 real solutions. So now this is useful when we actually go to graph this, because this tells me that this graph is never going to cross the x-axis. It's going to be somewhere up here, where this graph is going to cross it twice. So in a graph, every single quadratic looks like a parabola. It looks like a U. Just like every single linear equation always looks like a line. So the simplest quadratic function is f of x equals x squared. We call this U-shaped thing a parabola. And the simplest function only has one intercept at 0, 0. But one awesome thing about a parabola is that the two sides match exactly. And this property is called symmetry. If I was to take my paper and fold it right here, I would get exactly the same curve on both sides. And that line that I drew right there is your axis of symmetry. Your axis of symmetry is always a vertical line, so it's always x equals a number. The highest or lowest point of a parabola is called its vertex, and this vertex is always on the axis of symmetry. So if we go back to this picture here, here's my vertex, it's my lowest point, and it is directly on the axis of symmetry. If your A is bigger than 0, the parabola opens upward, so like this, and the vertex is the minimum point. But if your A is less than 0, your parabola is upside down like this, and your vertex is your maximum point. So identify the vertex of each graph, and then tell whether it's a min or a max. So we're looking for the point that's right in the middle of our parabola. And in this case, this point is over 4 and up 3. And because my parabola opens downward, this is a maximum. That's as high as my graph will ever go. Where this one over here is at -3, -3. And because my parabola opens upward, this is a minimum. That's as low as my graph will ever go. So now to get to actual graphing things. There's several critical points that you need to know how to find, and then those can help you connect the dots to make a nice pretty graph. So think back to when we were doing lines. Anytime something crosses the y-axis, we know that x equals 0. So in order to find the y-intercept of a parabola, we're going to make x equals 0 and solve for y. We can do the same thing for the x-intercept. Sometimes there's 1, sometimes there's 2, and sometimes there's none. But when something crosses the x-axis, that means y is 0. So we're going to plug that in and solve for x. Your axis of symmetry cuts your graph in half. So your axis of symmetry is right in the middle of your x-intercepts, or the average of your x-intercepts. And then your vertex is on the axis of symmetry. And we're going to use the x value of this. Because remember, your axis of symmetry is always x equals some number. So you're going to take x and plug into the equation to find y. So let's do an example. Find the critical points of the function f of x equals x squared plus 4x plus 30 and sketch a graph. So the easiest thing to find is your y-intercept. And remember, your y-intercept is when x equals 0. So all I have to do is plug in x equals 0. So I have, remember, f of x and y are the same thing. You can use them interchangeably. Y equals 0 squared plus 4 times 0 plus 3. Everything disappears except for the 3. So we just made one point here. The y-intercept is at 0, 3. So we can come over here and plot that. And then let's find our x-intercepts. And now our x-intercepts are a little more work, even though we're just going to plug in 0 for y, because we get something like this. And in order to solve something like this and get x by itself, we have to use the tools that we learned before. We can either plug this in the quadratic formula, we can complete the square, or we can factor. All of the ones I'm going to give you are going to be factorable, so try that. You want two numbers that add to make the number in the middle and multiply to make the number on the ends. That's going to be 1 and 3. So we get x plus 1 times x plus 3. And then we can use the zero product property to find out what x equals. So we get x equals -1 and x equals -3. So we just made two more points. We plugged in 0 for y and we got out -1, 0 and -3, 0. Now the next thing we need to find is the axis of symmetry, and that is right in between our two x-intercepts. So you take your two x-intercepts, you add them up, -1 plus -3, and divide by the number of them you have, which is 2. So we end up with -4 over 2 or -2. And remember, your axis of symmetry is always x equals something. So this is a line right here, x equals -2, where my graph gets cut exactly in half. If I was to fold my paper on that line, I would end up with the same thing on both sides. So then the last thing we're going to find is our vertex. And remember, this vertex is on the axis of symmetry. So if it's on the axis of symmetry, I know part of my point already. I know the x part is -2. I just need to find the y part. So what I'm going to do is plug it into my equation. So I have -2 squared plus 4 times -2 plus 3. -2 times -2 is 4. Subtract 8 and then add 3 and you end up with a -1. So that's what y equals. And I can plot this point. -2, -1. Now we can kind of see the makings of a parabola, but you can add one more point on here because we know we have the same thing on both sides. So if this y-intercept is over here, we know there has to be like a mirror point on the other side. And then it's really easy to see that we just created a nice U. And that's it. So let's try one more together. Let's find all the critical points of x squared plus 6x plus 9. So the first one we're going to find is the easiest, the y-intercept. And remember, that's when x equals 0. So we get y equals 0 squared plus 6 times 0 plus 9. All that's left is the 9, and we just made a point, 0, 9. Now if we go to graph that, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's about right here, a little off the graph. And then let's find our x-intercepts. Remember, those are when y equals 0, so we can plug 0 in for f of x. And just like before, we have to use one of our other methods to solve this. So you could use factoring, completing the square, or the quadratic formula, but factoring is going to be the easiest. If I want two numbers that add to 6 and multiply to make 9, they're 3 and 3. So we get this twice. which means when we solve, we only end up with one answer here, which is fine because that just means we have one x-intercept at -3, 0. So 1, 2, 3. There's the only one. Now, because we only have one x-intercept, that makes finding the axis of symmetry really easy because it's the average of our two solutions. And if there's only one, it has to be on that line. So we have our nice axis of symmetry there. And then the last thing we have to find is our vertex. So remember, your vertex is when x equals 3. All we have to do is plug that in and find out what y is. So we get y equals -3 squared plus 6 times -3 plus 9. So this gives me positive 9. If I do -6 times 3, that gives me -18. Plus 9 more, this gives me 0. So my vertex is at -3, 0. Whenever you end up with only one x-intercept, your x-intercept and your vertex are always going to be the same point. Your line of symmetry, or your axis of symmetry, will also be on that point. So remember, we can find one more point if we go over 3 in this other direction, because we have to have something that's symmetric. And then we can create a nice curve that should go through those points. So try your hand at one. Find how many solutions this has, find your critical points, and then see if you can make a quick sketch. You might have to count by 2 or 3 to get it on this graph. So write down any questions you have and we can go over them in class. Enjoy your night.